All right, so here's another video about polynomial graph characteristics. And if you notice, for these problems, it says find the x and y intercepts for the following polynomial graphs. Find how many of the solutions are not real. So we're looking at complex solutions that are not real. We're also looking for how many solutions that are real. But when you're doing that, you can just find the x-intercepts for that. It'll make more sense once we start doing these problems. All right, so this first one here, let's do the x-intercepts first. We have an x-intercept at x equals 1. So the x-intercept for this one is going to be at x equals 1. Okay, the y is 0 for that. So if you wanted to write this as coordinates, you can write 1, 0. Okay. The y-intercept is going to be right here at -1. So we're going to write y is equal to -1. And if you want to write this as a coordinate, you can write 0, -1. Okay. And then it says, find how many solutions are not real. Well, this is linear and you should only have one solution. So in that case, the one solution for this one is going to be represented by that x-intercept. Okay, so it says find how many of the solutions are not real. There are no non-real solutions. There's only one real solution. Based on the information that's given here. There's no non-real solutions. All right, this next one is quadratic, and we're going to look for the x-intercepts for this. If you notice, it does not have any x-intercepts, so I'm just going to write none. There are no x-intercepts. The y-intercept, there is one right here at y equals 2. And if you wanted to, you can write it as coordinate 0, 2. It does not matter. I would accept either of those for the y-intercepts. Okay, now it is quadratic. Minimally, I guess I should say, it is quadratic. So means there should be at least 2 solutions to this. And because there's no x-intercepts, that means there are technically 2 complex solutions to this. And these complex solutions are non-real. So there's 2 complex solutions and they're non-real complex solutions, which means they have an imaginary part to them. We're not going to worry about what those solutions are for this video. We're going to explain that in a different video. For now, I'm just kind of going over the concepts of this. So I'm just going to write 2 complex solutions. Both of those complex solutions are non-real. We're going to solve those some other day. All right, 13, if you notice, there is a relative extrema here and here. So that means the parent function for this is going to be cubic. All right, so it is going to be cubic, which means there should be minimally 3, or I should say the minimum parent function for this would be cubic. It could have a higher degree. There's not enough information here to tell us that, but let's just say minimally it is cubic. And again, it's based on the relative extrema here and here. So the degree for it will be 3. So I'm just going to write y equals x to the 3rd for that. The solutions for it, the x-intercepts anyway, there's 1, 2, 3 here. So the x-intercepts are going to be at x is equal to -3, 0, and 1. And again, if you want, you can write that as coordinates. I'm just going to keep it like this for the x-intercepts. The y-intercepts, there can only be 1, and it's just going to be at 0 as well, so we're just going to write y equals 0. And if you wanted to, you can write 0, 0. Doesn't really matter how you write your answer for that, for the y-intercept. Now, if it is cubic, which minimally it is, you would say that there are no non-real solutions. Because if it's cubic, there should be 3 solutions, and there's 1, 2, 3 here, and since they're all accounted for, there are no other non-real solutions. Now, again, this is minimally, this could technically be x to the 6th or x to the 9th or something like that as well, where there would be non-real solutions, but I'm assuming the minimum for this, so I'm going to assume minimally this is cubic, and because there's 3 real solutions, there cannot be any other non-real solutions because, again, fundamental theorem of algebra states whatever the highest power is for the polynomial, that's how many solutions it has, including multiplicity, but we'll go over multiplicity in the next section. All right, this next one, okay. Now, believe it or not, this one actually is an x to the 4th as the parent function, but it doesn't look like that, so you can't really assume that. But when I actually did create that graph, I did it as x to the 4th just to kind of show you. But minimally, let's just say that it's x squared. Okay, you don't actually know, but the reason why we can say it's for sure x squared is because there is one relative extrema, and then you add 1 to that 1 to get 2. So minimally, it's x squared, but it actually is x to the 4th, and there is one solution right there. Okay, for the x-intercepts, you're going to say x-intercept is at 0, 0. I'm just going to write it as coordinates, and the y-intercept is also at 0, 0 as well. And there is one solution on this. As you can see, it's that 0, 0, but it is technically x squared, but that just kind of leads us to the multiplicity of this. Because it's x squared and there's one of them right there, and there cannot be one complex solution. Complex solutions always come in pairs, if you remember from the previous unit. There are no non-real solutions on this. And again, that's assuming a lot. That's assuming that it's x squared, and which is what I did write down there. So that's kind of what I'm basing my answer off of. Again, we'll go over in more detail the nuances of this in a little bit later. All right, this next one, oof, lots to break down on this one. So let's count how many relative extrema we have for this. It looks like we have 1, 2, 3, 4. Okay, so remember the relative extrema rule, you just add 1 to it and you should have 5. So lowest possible degree for this would be an x to the 5th. Okay, which means there should be 5 solutions, and if we count them up, the solutions for the x-intercepts are all real. So 1, 2, 3, 4, 5. So the x-intercepts for this one occur at x equals -2, x equals -1, 0, 1, and 3. Now, again, we're assuming that the lowest possible degree here is 5, and there is 5 solutions there, so that means there are no non-real solutions for this one, so we do not have to worry about that. The y-intercept for this one is going to be at 0 as well, so I'll just write 0, 0 in there, because that's where it intersects right there. And as I stated before, there are no non-real solutions for this if we are assuming that it's x to the 5th. So that's basically a brief breakdown of polynomial graph characteristics involving the x and y intercepts. There was a lot of assuming on this one. We were just doing the lowest possible degree for these. We are going to go in a further deep dive into other possible degrees that it could be. I kind of alluded to some of it while we were going over that, but we're going to go, it'll be a separate video of just going into the other possible degrees and what that really means. So if you have any questions about anything in this video, let me know.